I'm Jonathan Russolinelli. I'm a soil scientist at Cornell University. Today we're going to be doing the second phase of our soda bottle soil science project. Today we're basically going to be assessing compost. And so what you're going to need is you're going to need the top of bottle number 2 and the bottom of bottle number 1. And we're basically going to use this as a funnel to make compost tea in. We're basically going to use this as a petri dish to put some seeds in and basically assess the quality of that compost tea that we make. And so how we're going to do this is basically pour some of that material into this container. Now today I'm going to actually do 4 different soils or compost materials so that you have a sort of a broad sort of vision of what we would do. But what I'm going to be putting into our funnel today is this is Cornell compost, just so you can see what it looks like. It's pretty, this is about a year old, a little bit older than a year old. It's basically material that is from the barns and some of the greenhouses and stuff like that. And we're basically just going to pour this into the beaker. A little bit there. You'll notice that my cap is on my beaker because what we're going to do is we're going to pour water into this and then let it sit there for about 15 minutes, as I said earlier. We're just going to pour some water in it. You can use tap water for this, it's not a big deal. Pour the water in. I'm going to bring it up to just to the surface, about there. And I'm going to stir it around a little bit just to give it a stir. Okay, let's need a little bit more water. We're going to call that a day. Now I'm going to slide this over. We're going to let this sort of basically right now we're just going to sort of sit and say 15 minutes from now we're going to come back to this. But during that 15 minutes, what I'm going to do is show you a couple of other soil materials that we have. I'm going to basically do 3 other soil materials. I have a vermicompost that we're going to be doing. I also have some compost from New York City. And I'm also going to do the soil that I'm putting in my soil column just to see if we've got any sort of benefits from that from germination. Soil-wise, what do these guys look like? This is the soil that is from my bed, so you can see what it looks like there. The compost that is coming from New York City, sort of open this up so you guys can see that as well. Basically, this is stuff off the street. This is sort of street trees and stuff like that, debris from there. It's also yard waste, and there is actually some food waste in here as well, but it's mostly yard waste. The last one we're going to be doing is we're going to be doing a vermicompost. So this is a compost that's been processed by worms. It's got some shells in there, egg shells and things like that. We're going to be basically using that as well. Because I only have the 1 bottle, what I'm going to be doing is I'm going to be basically using these little sort of tea bag things that we've made. These are little dippers. I'm going to fill them up with the soil. I'm going to put them into the appropriate beaker, and then I'm just going to fill the beaker up with water. I'm going to let that sit for 15 minutes. Okay, so this is vermicompost. Up, put it into the appropriate container, just like that. Okay, I've got another one here, vermicompost. Do the Cornell, the New York City compost. Put that into the New York City compost. And the last one is, what do I got left? I'm looking at my stuff out of my raised bed. I'm just going to scoop this in. This is a little bit off, so you can just sort of scoop this. Just enough. So these tea bag things basically have a little screen on the bottom. I'm going to fill it up with water, the same water that I used on our compost. Pouring it on the top so the water actually pours through. We'll do that for all of them. just enough in there. This up and down a couple times, kind of like a tea bag. You do not have to use these sort of tea bags to make this. In fact, most of the time, basically, we just sort of dump it directly into the water and then sort of pour it out and sieve it out, so we just get the liquid afterwards. And so I should probably talk about what we're doing here. What's the intent of this? Compost tea is a strategy for basically to get the things that are soluble in the compost and basically use it for primarily for fertility. What we're going to do is basically do the same thing, and we're going to take the liquid from this compost, make this compost tea, and we're basically going to pour it into beakers or petri dishes, and then put some seeds in them and see how the seeds perform. And the concept here is that if you have a high quality compost tea, you should see a benefit to the seed germination. So we're going to let these guys sit for a little bit, and we'll be back in about 15 minutes. Hey, we're back. So it's been about 15, maybe 20 minutes. We've let the compost sort of steep in the water. And what we're going to do now is we're basically going to get the tea out and put it into the containers that we're going to use as our bioassay chambers or a petri dish. So we want about, for some of these we're going to use, literally we're going to be using petri dishes. For yours, you're going to be basically using this, your petri dish, the bottom of the soda bottle, and what you want is about 50 mLs of liquid into this. And you got to be a little bit careful because you're going to have a lot more than 50 mLs over here, so you might want to have a spare or larger volume of material or to collect this. So what I'm going to just do is put this into a beaker. I'm going to take the top off, and I'm just going to let it pour out, slowly drip out. Now that it's been totally absorbed by the soil material, it's going to slowly come out there. If you have a hard time with this, because we're really just looking for the tea, you don't have to preserve this. You can sort of squeeze this down and sort of like a sponge and let the water come out. While we're letting this one go, we're going to take a look at these other guys. These are the dunkers that we're using as tea bags. You can sort of see that these guys have changed color. I'm going to turn a little bit so you can see these a little bit better. And what you're going to do is you're going to basically do the same thing with these guys. And I'm going to pull the dunkers out. I'm going to drip out a little bit, put it on this to the side. Dunker this one, drip out to the side, and then take the last one, slowly drip out. This one is more of a soil, and slide that in there. I'm going to set these to the side right now. Okay. With these guys, because we're not going to be using the bottom of the bottle, what I'm going to do is I'm going to just pour the liquid into the bottom of these petri dishes. I know you guys don't have them, but we're only doing the one, but these are just comparisons. And I'm basically going to take the label off of this and put it on the top for now so we don't mess up the labeling. I'm just going to pour enough to fill the bottom of the petri dish. Just enough there. Put the top on, just for now. Okay, I'm going to do the same thing for the next one. Take this label off. I'm going to put it on my next one. I'm going to pour out some little liquid in there, just to fill the bottom of the petri dish. Just enough. Top on that one. And this guy off. That. Fill this one up. Put the top on this one as well. So this one's still dripping out. Don't have quite enough there yet. I'll give it a little squeeze and see if we can get some more out. It's all coming up to the surface rather than off the top, off the bottom. So what I think I'm going to do is actually pour some the top here without actually spilling it right into the beaker or my base. See how dark that is? A little soil in there as well, that's okay. Oops. squeeze it out. Okay, I'm going to slide this to the side as well. So right now we've got 4 of our teas, and what we're going to do with these guys is basically we're going to put seeds in them. We're going to put 10 seeds in them so that makes the math a little bit easier. We're basically going to be putting in bean seeds. Now the bean seeds that I have are these little Roman beans. Green beans from Goya. There's a bunch of other different kinds that you can get. Lost my other bean bag right here. So there's a bunch of different kinds that you can get. This is the Goya red kidney beans. These work really well. What you basically want is a fairly large bean because we're going to be using these beans later when we do our soil columns and to watch them grow. There is a trick to beans to get the beans to germinate. So what we're going to be doing is we're throwing these 10 beans into each one of these containers. We're basically going to watch them germinate or look at how many of them germinate. And then ultimately we're going to look at how much root length we get out of them. There is actually a trick to germinating bean seeds. There's actually 2 tricks that you can use. One is you throw the beans in some water overnight and let them soak. So they get the water, they start pulling water into them. Another trick is actually what we do is we call scarification, where you'll take a bean and you will actually scratch the seed coat so that liquid can get into the seed faster. That water, when it goes into the seed, will start germination. And so I'm going to show you a little trick that we use to increase germination. Now, the trick is called scarification. And basically, I have a little emery board here. You can take a seed, and you're basically going to scrape the side of it. You want to avoid, and I'm going to draw this, you want to avoid where the root and the shoot are going to come out. So this is a bean here. I'm drawing this bean, and they generally have sort of this sort of kidney shape, okay? And right in here is usually where the root and the shoot will come out. So when you scarify, you don't want to get near this. And if you look at the seed, you'll see it. Basically scarify over here on this side. It'll let the water get into the seed and hydrate so that it can start germinating. So what I'm going to do here is I'm going to erase this, and I'm going to show you how we do this. Okay, put the emery board right down here. So the side of the seed I don't want to touch is that side. Notice that's sort of that kidney shape. Okay, I'm going to take the other side. I'm just going to do a real quick scrape on it. You can see that there's a little sort of opening there. Okay, and I got another seed. I'll do the same thing here. Again, you don't want to touch that side. You want to do someplace on the other side. So we'll try right there so you guys can see that's what it looks like before. That's what it looks like after. Just a little bit of scraping off of that seed coat. Okay, so let's get rid of this out of the way. Okay, the other thing that's going to happen here is once you put these seeds in, we're going to seal them so that the water doesn't come out. You don't have to do that with yours, but the water is going to slosh around a little bit. And what I'm going to suggest you guys do is put some paper towels or tissues or something like that into the bottom. This will just sort of hold the water in place and, more importantly, actually hold the seeds in place. You want to put this in before you put the seeds in, though. Okay? And then you're going to put your 10 seeds in. Sort of scatter it around. I've scarified all of these. Basically, going to scatter them around so that you have good placement so you can see them all. Here's 5, 6, 7, 8, 9, 2, 3, 4. Actually, it was 9, and there's 10. That guy over there. So 1, 2, 3, 4, 5, 5, and we got one extra in there. So I'm going to pull that one out. Okay. Now, another kind of little cool trick is actually this top. We're going to use this top. Now, this happens to be Cornell compost. And I'm actually going to pour this back into the Cornell compost container because I'm going to show you something really kind of cool what you can use with this. Okay, pop that out. Okay, I'm going to do a quick rinse on this guy, so hold on for a second. We're going to make a miniature greenhouse. The term that is used is a cloche or a cloche. It's basically a small miniature greenhouse that you would basically put over your plants out in the field. And we're basically going to do the same thing with this. I'm basically going to tuck this inside rather than outside, which is what you'd usually do. But because of the plastic bottle here, tuck it in the inside of this to sort of seal the container. There's a little hole on this side and this side, and what it'll do is it'll keep the moisture, and if it's outside, it will actually keep the warmth in the container. It's a cloche. It's a sort of single plant strategy. That's what we're basically going to be watching for a week, and every day what you're going to be doing, and I'm going to move this out of the way so you can see. Every day you're going to be coming back and you're going to be looking at these seeds and you're going to see if it's germinated. Now germination just means that I've got a little bit of root or a cotyledon coming out here, a seed, the root or the shoot basically coming out. If you see a little bit of it, that's germination, and you'll just mark it down. And what you want to do is for every day, see how many seeds have germinated. So if I don't have anything on day 1, I'm going to put a 0 there. Let's put a 0. Okay, on day 2, if I've got 1 seed that's germinated, I'm going to put a 1 there. On day 2, if I have a second seed that's germinated, I now have 2 germinations, and I'm going to put a 2 there. Day 4, if I have maybe 7. Now I would point out that don't expect to have all of these seeds germinate. 7%, 70% germination is actually fairly good. So you might have a series of days where you basically have the same number, and then on day 8, I might have 1 more, okay? That would be the total number of seeds that have germinated during that period of time, and then on the last thing right here, germination rate for day 8 would be 80%, 8 out of 10. Foolish beans on that one? All right, this you're basically gonna put in a sort of a darkish place. Don't put this on the window because you don't want these things to overheat, especially with this cloche on top. But you can put it in a sort of a room temperature area and just sort of let them germinate and them do their thing. Now there's one more thing I want to talk about. I'm going to let these guys slide these to the side. I'm going to do another drawing here. So here's my bean seed. I'm going to draw my bean again. Okay, here's my sort of bean. Okay, and here's where you're going to be seeing that root and shoot coming out. Germination is just basically just a little piece sticking out. Okay, that would be enough for germination. Now, I'm also interested in root elongation. The first piece of growth that comes out of the seed is actually the root, and it's going to be moving downward into the soil. Obviously, we don't have a downward motion. They're basically going to sort of spread out, looking for axis to go downward. I want us to actually have some idea about how long these roots elongate. Compost tea is supposed to do basically 2 things. One is it's supposed to, at least with seeds, it's supposed to help increase germination, but it's also supposed to help with growth rates. Basically, it's the hormones and things like that that are in the compost tea that are supposed to accelerate this. So we want to have some idea about how quickly this root accelerates. So you've got 10 seeds, and I'd like you basically to measure those seeds over the period of time. This is average root length, okay? So basically all 10 seeds, I want you to average out. So that means if there's 1 seed that has not germinated, let alone looking at root elongation, that would be 0 towards your average. So think about it this way. I could have 10 seeds that have elongated about 5 millimeters, but I also could have 1 seed that's elongated 50 millimeters and all the other ones didn't do anything, and the average on those guys is going to be basically 5. Foolish beans on that one, guys? So you're basically going to put the average of root elongation over the 7 days and then do whatever that last one is, and let's imagine that it's 15 millimeters. Okay? That is the intent for the compost assessment. Okay, talk to you later in a few minutes. Hi, we're back for the last little component of the seed germination and compost assessment. There's a couple more things to think about. First is, and actually something I totally forgot about talking about at the very beginning, on your table you also have a little slot there that says what kind of seed it was. You should actually label it in there. In our case it was Roman, so I'm just going to say Roman, right, Roman there. Okay. What's going to happen over the next 7 days is that the plant itself, the seed itself, is going to start sucking that liquid in. And if it starts sucking that liquid in, you're certainly going to have an environment where you're going to start losing water in that volume. If the container starts to go totally dry, do add some water. Basically, tap water is fine. The hormones and the nutrients and things like that that we're interested are already in there. So adds a little bit of water there, particularly if you put this on a windowsill or something like that, it's going to get hot. Related to that, if it does get really hot and you feel fairly comfortable about this, basically you can take the top off and sort of let that be a chimney to open it up, and if worse comes to worse, just basically take the clouche off and just basically let it be an open petri dish. The petri dishes that I used, I literally sealed on the outside of them with parafilm so that we're not going to have any evaporation coming off of them. But just keep that in mind. As these things start to dry, you're probably going to want to add water to them. All right. Now, there's one other thing that we want to talk about, and that's actually the compost itself. What was the source of that compost? Where did you get it? In the case of this guy, we're basically using Cornell compost, and so I'm just going to write Cornell over here, Cornell, so we know where it came from. Okay. We also want to have an assessment of it. We want to have some idea about its quality. And what we've got, I'm going to give this is online, but we're going to show it to you right now. We have basically a compost ranking sheet right here. And what you're going to do is you're going to basically look at the color and you're going to smell the material to have some idea about the quality of that material. So I'm going to go get that compost. So here's that compost. We're basically going to look at it. I'm going to put it right there. Slide this over a little bit. We're basically going to look at that color. Now that looks pretty dark to me. It does not look like fresh material. It doesn't even look like it's actually been sort of processed a little bit. It looks like it's been processed for a long time. So I'm pretty much going to give this a ranking of 1. So on the color compost rating, I'm going to put a 1 here. Okay. Now the other thing we want to do is we want to have an understanding of how it smells. As compost decomposes, as the organic material decomposes, it volatilizes a lot of different types of degasses, a lot of different types of smells and gases. And you can literally smell that. Now I'm not going to treat this, in a sense you should actually treat it this way. You can sort of treat this like a wine glass, and you're basically going to put your nose in there and smell what it smells like. And you want to assess that smell. And there's a number of different sort of smells that we give you sort of suggestions. Sort of the classic smell that you get when you smell a nice fresh earth. That's really what you're trying to look for. That's what you're striving for when you're doing compost. That smell is actually microorganisms. It's actinomycetes. It's a smell that type of organism. It turns out that it's actually a really good organism to have around because they're very sensitive to toxins and things like that. A bunch of them are. And so you can sort of smell this. What does it smell like? This smells very earth-like to me, so I'm going to give this a rating of 1. But if you smell things like ammonia or pine sol or rotting smells and things like that, you can sort of figure out what that smell is. This compost is about a year and a half old. It's been sitting out curing for a while. And it's actually fairly high quality. Actually, it's a very high quality compost that we're using. So I have high hopes for the compost tea and see what we get for germination. Talk to you later.